Okay, everyone, today we're going to take a look at infinite series and see if we can find some relationships here. So let's start with an arithmetic one. So given our summation notation, we'll start at n equals 1 and we'll go to infinity. And we'll say that the rule is 3n. So let's generate some of these numbers. 3 times 1 is 3, 3 times 2 is 6, 9, 12, 15, 18, and so on. And because this is infinite, right, we're going to put the dot, dot, dot. And if I start adding up these numbers, like let's say that the first partial sum is just the sum of the first number, which is 3. The second partial sum is the sum of the first 2, which is 9. Then the sum of the first 3, which is 18. Then the sum of the first 4, which is 30. And if I keep going, the sums will increase. So what's happening here is that you probably won't, or you definitely won't be able to find or evaluate this series, right? Because those sums keep getting bigger and bigger and bigger and bigger because the numbers in the sequence kept getting bigger and bigger and bigger and bigger. And if you continuously add bigger numbers together, you're just going to get a big number. So we say that this series diverges, okay? So diverges means that the sum does not approach a specific number, it goes off to infinity. What happens if the numbers subtract, right? What if the numbers get smaller? So if the numbers get smaller, let's try negative 2n. So that sequence is going to look like negative 2, negative 4, negative 6, negative 8, negative 10, and so on and so on. So first partial sum, negative 2, second partial sum, negative 6, third partial sum is negative 12, fourth partial sum is negative 20. And as you can see here, all of these partial sums are just going to get more negative, right? So this series also diverges. Okay? Let's take a look at a geometric one. We'll start at 1, we'll go to infinity of 2 to the n. So if I generate the numbers, 2 to the first is 2, 2 squared is 4, 2 to the third is 8, 16, 32, and so on and so forth. So first partial sum is 2, second partial sum is 6, third partial sum is 14, fourth partial sum is 30, and so on and so forth. So again, since the numbers in the sequence keep getting bigger, if you continuously add them together, the sum will continuously get bigger. So this series diverges. Okay? So now you're saying, well, when does it ever not diverge? So let's take a look at a geometric series that's infinite, that doesn't diverge. So now I generate the numbers in the sequence. I start with 4. Every number is going to get cut in half. So 4, 2, 1, 1 half, 1 fourth, 1 eighth, 1 16th, and so on and so forth. So if I take these partial sums, what you should be noticing, at first you think, okay, this is probably going to diverge because these sums keep getting bigger. First partial sum is just 4, second one is 4 plus 2, then 4 plus 2 plus 1. But then, what's going to happen is that you're then going to add a half. So you get 7.5. Then you're going to add a fourth. So you get 7.75. Then you're going to add an eighth. So you get 7.875. And you're thinking, these numbers are increasing awfully slowly. If I think about it on a number line, right? Here's 4, here's 6, here's 7, and here's 8. I know that those aren't really equally separated, but that's fine. Start with 4 and you add 2. Then you add 1. Then you add a half. Then you add a fourth, which in this case would be half of a half, so it would land here. Then you add an eighth, which is half of a half of a half, so you would land here. Then you add a 16th, which is half of a half of a half of a half, which will put you here. So you are approaching a number here in this case. So because you're approaching a number, because the R value, because the common ratio is a number less than 1, you are approaching a number. So in this case, we say that the series converges, which means that it approaches a sum. Okay? Now this happens when the absolute value of R, because this is going to be true if R is negative, the numbers are just going to go back and forth in terms of their sign. This is true when the absolute value of R is less than 1. So there's a formula. The infinite sum equals A sub 1. In this case, we'll use 1 because we're starting with n equals 1, but it's really whatever term number you want to start at, divided by 1 minus R. So in this case, A sub 1 is 4, and you're going to divide by 1 minus a half, which gives you 4 divided by half, which means that the sum approaches 8. Which makes sense because you keep taking halves here and getting closer and closer and closer and closer and closer and closer and closer to 8. Okay? So let me give you one to try on your own. So pause the video, wait for the answer. It's 18. Did you get it right? Good job.